The cat sat on the mat because it was tired. What does it refer to? The cat, right? A mat can't be tired. You figured that out instantly. But how does AI do it? The answer is the invention that gave birth to ChatGPT, attention. And this mechanism is eerily similar to a physics phenomenon, resonance. Welcome back to Minimal Lab. Let's break it down. First, let's get the problem crystal clear. A word's meaning is never decided by the word alone. Take bank, a riverbank in one sentence, a savings bank in another. Meaning is decided by its relationship to the words around it. Older AI models read a sentence one word at a time, strictly left to right, like peering through a keyhole. One word at a time. And as it read on, everything earlier just faded away. By the end of a long sentence, it had forgotten almost everything from the start. And remember, last time we talked about this. Work that can only happen in order can't be parallelized. You could hand it a GPU with thousands of cores, and reading one word at a time would waste every one of them. What we need is a mechanism where every word in the sentence can see its relationship to every other word, all at once. Now physics enters the picture. Picture tuning forks in resonance. Strike one tuning fork, and its vibration travels through the air to the forks nearby. But only some of them start vibrating too, the ones with a matching frequency. A fork tuned to a different pitch? The sound just passes it by. Inside attention, every word does exactly this. Each word carries three things. 1. A query. A broadcast that says, "Here's the kind of partner I'm looking for." 2. A key. A response frequency that says, "Here's what I am." 3. A value. The payload that says, "If we resonate, here's the information I'll hand over." The word "it" broadcasts a query. I'm looking for something tired sounding that appeared just before me. And the key for cat resonates strongly back. Mat vibrates a little too, but weakly. The strength of that resonance is exactly what becomes the amount of attention. Now let's look at the heart of the mechanism. In attention, every single word runs this resonance check against every other word, not one at a time in order. All pairs, all at once. Once all the resonance strengths are in, here's what happens next. Each word blends together the values of everything it resonated with, weighted by how strongly. In physics terms, that's a center of mass calculation. The heavier the weight, the stronger the resonance, the harder it pulls the center of mass toward it. The new meaning of "it" settles at a point pulled strongly toward cat, which means, in this sentence, "it" essentially becomes the meaning of cat. That's one round of attention, and this gets stacked, dozens of layers deep. In the earliest layers, simple relationships between words. The deeper the layers go, grammar, context, the flow of the whole passage, the more abstract the resonance it can pick up. The T in GPT, the transformer, is really just this resonance device, stacked dozens of layers high. Attention didn't change the world just by being smarter. Every word checking resonance against every other word. Look closely, and that's a giant grid of multiplications. In other words, matrix multiplication. Remember our conclusion from last time. Simple, massive, independent multiplication is exactly what a GPU loves. Unlike the old AI models that could only creep forward one word at a time, attention processes the entire sentence all at once. Thousands of cores, computing every pair's resonance simultaneously. Which means the transformer was the first language mechanism ever shaped to fit parallel hardware, the GPU, perfectly. It didn't win because it was the cleverest idea. It won because its shape matched the physics of the hardware. The title of the 2017 paper said it best. Attention is all you need. But attention comes with a physical price tag too. Every word resonating with every other word means this. Double the number of words, and the number of pairs quadruples. 10 times the words, 100 times the pairs. The cost grows with the square of the sentence's length. In physics terms, that's the same structure as the n-body problem, where every particle pulls on every other particle. The more particles you add, the more the combinations explode. This is exactly why ChatGPT has a limit on how much it can read at once. Its context window, and much of the technology built for handling long documents, at its core is really about taming this squared explosion. Let's put it all together. The problem, a word's meaning is decided by context, by its relationship to what's around it. The key, resonance. Information flows from whoever matches your query and key. The mechanism, all pairs resonating at once, blended together through a center of mass calculation. The winning move, that whole process is matrix multiplication, a perfect fit for the GPU. So what looks like ChatGPT understanding a sentence is really just words resonating with each other, layer after layer. Now you've seen the heart of modern AI, the core of the transformer. But one big mystery still remains: an AI that understands sentences through resonance. How does it actually choose its next word? Next time, we'll unpack the key to that. Temperature, explained quite literally as the physics of temperature. If you want to keep understanding AI through physics, subscribe. There's a free notebook in the description where you can watch attention's resonance with your own eyes. See you at the next token.